Yeah, so I thought I'd give you a day in the life of a solar engineer troubleshooting in Western Europe. Right, so this device came from China, but I'm reading the English user manual. And you'll see I got various annotations on the instruction manual, which essentially on the front says I can put in 120 to 450 volts DC in my own writing, so I trust it, which is a summary of the information contained in this booklet. Would have been interesting to see that on the side of the machine, but it isn't. Now, it was reporting an error, which I'm about to uncover. This one, number 13, which says solar charge stops due to high PV voltage. I looked at the front cover. I said the total PV voltage is 450 volts DC. So off we went to look at the machine, and I'm thinking to myself, 450 volts DC, crikey. I'm going to put my instrumentation across the 450 volt DC line into this device and see what its volts are. There they go, in there. Believe it or not, those are the wires I'm using to carry 450 volts DC. Okay, so this machine is no longer showing a fault. How delightful. It doesn't have any brand identification on it at all. This is my favorite device. It has a brand identification on it. It is a 48 volt unit. This is a 24 volt unit. I don't really care too much how I wire my 24 volts up, but 48 volts you've got to be a bit more careful. Right, so that's good. We've just checked on that, because what I did was dial back the maximum amps rather than change the solar panel configuration, and I didn't have to touch the terminals myself because the machine read out 445 volts DC. Now that's within spec on this rather beautiful day in Somerset, but until now that system has not been functioning properly today, and it is now about 3 o'clock in the afternoon. Well, you could say I'm the most chaotically organised solar engineer in the fricking country, but yes, I probably am, because that machine should be reporting to my phone. It is not performing correctly. Error code 13 doesn't mean the voltage is too high, it means I'm trying to put too much power through the unit. And by dialing back the amps, it looks like you can get over the issue of you've got 440 volts on the DC supply side. Now, you might also think that I'm a little bit cavalier with DC voltages at what they come out of solar panels at. And one of the things I'm most principally interested in is cost of balance of plant. So for instance, in my system I've got solar panels, which I think of as the primary source of energy, but the balance of plant is the battery and the solar charge controller and its mean point power tracking and so on and so forth. Now that controls the voltage that comes into that device, but once that device sends it out into 24 volts DC, the volts are not divided, generally are not divided or accessible as a usable power feature, but in fact they are, because at each intersection of the series battery that I'm charging, because it's lead acid, I'm at 2 volts. So I have an option, and the option at the junction of about 2 volts between two positive conductors is an opportunity to generate hydrogen. The same thing could be said of the junction between two 3.5 volt or 3.2 volt lithium iron phosphate batteries must also be seen as an opportunity to generate hydrogen as well as putting it into a lithium battery. And it's a choice decision at that stage, and actually I'm convinced that surely we can engineer things where the battery and the electrolysis machine work in harmony under the control of the power electronics being provided by the box on the wall. Now, why would you want to do this? Well, because controlling the 3.2 or 2.0 volts into your electrolysis cell is quite an important design feature. If you're not careful, the cost of cabling of high current at high current over long distances in order to get it into the cell is quite considerable. Now, if you've got the right terminals on your batteries, you can combine them, I believe, quite efficiently in terms of space, and therefore I'm curious to know what the optimum mix of electrolyzer and battery space is in a system which is dual purpose, both capture of energy in hydrogen and capture of energy in lithium ion. Because there are many places, I'm convinced, where space is not at a premium to the extent that we sometimes think it is. In a vehicle, of course it's at a premium. In an aircraft, it's even more at a premium, and the weight considerations are enormous. But I'm just basically trying to envisage systems which are at ground level, on hard concrete, level ground, and basically serve as some kind of absorber of power and producer of dispatchable on-demand electricity. Because I'm renewable electricity, I'm convinced that's the answer. Now, within this entire system, there's an important component which we have not yet discussed, which is the fuel cell, that is the reconversion back of the hydrogen into electricity in order that we can determine its efficiency full round circle, and also that we have routes to market, because critical amongst this is where's the money coming from? Where's the income coming from in order that the integrated system actually can stand on its own 2 feet and justify its growth? And the reason we're going down the all options must be open here is because principal amongst the considerations are going to be things like, can we provide grid connection, grid quality control, security of supply, penalties for undersupply at promised times, things like this, which are outside of initial feasibility study, but they are all part of how we will have to do business if we are to sell dozens and dozens or hundreds and hundreds of megawatts of battery power in the UK. Now notice I'm saying megawatts, not gigawatts, because I think probably the gigawatt scale projects are well underway, but I don't know really. But I do know how to identify, I believe I know how to identify, having made a study of this connecting to the grid aspect of our proposal, that I know the importance of it. I control land immediately adjacent to the station. There is a physical opportunity in factory space near the substation, and the substation already has a connection to that point of to that position. There's some balance of plant in order to get it from. I'm sure there will be balance of plant. But the point is that well, you've asked me a very important question. You've asked me what voltages are we working at, and I'm going to give you a proper answer to that question, I think. Okay, it's coming.